We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet, they are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 6/10% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can't physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they are made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has two of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These two space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
Hello, Brightsiders! Today, we have a very unusual topic. We are discussing toilets in space. Do you know that the first astronauts didn't have a toilet at all? The first American astronaut and the second man in space, Alan Shepard, found himself in a very awkward situation. His flight was only supposed to last 15 minutes, so the engineers didn't install any toilet inside his spacecraft. Shepard took his seat in the spaceship about an hour before the scheduled launch. But due to weather conditions and technical problems, the rocket launch was delayed by 2 hours. Alan Shepard was lying on his back in the spaceship all this time. At one point, he felt the need to go number 1. He reported it to ground control, but if Alan Shepard got out of the rocket to do his business, it would delay the rocket launch indefinitely. So, ground control didn't let him out of the rocket. The only option for him was to try and relax. In the end, he did his business right inside his suit. It's a good thing his spacesuit and the clothes underneath were made of cotton, which is quite absorbent and soaked up all the liquid. So Alan Shepard completed his flight in comfort and relatively dry. Though he still needed to turn off the sensors in his suit because if they got wet, they could cause a short circuit. But the first man in space, Yuri Gagarin, managed to solve the same problem before the rocket was launched. When he was transported to the rocket by bus, a couple of minutes before they arrived at the rocket, he asked for a stop and relieved himself. This way, Yuri Gagarin made his nearly 2-hour flight in comfort. So remember, always go to the restroom before a long trip. Later, NASA took care of astronauts' call of nature using the following device, as they sent people into space on more extended missions. It consisted of a cylinder that an astronaut had to put on. Astronauts placed this system on straps near their waists. This cylinder was connected to a bag that collected all the waste. That was the first NASA toilet, comfortable and cheap. NASA also tried to experiment with astronauts' diets. It was all about slowing down the digestive process and prolonging the time between eating food and drinking water to produce waste. One of the astronauts, John Glenn, tried this method out. His flight around Earth lasted about 5 hours. A special diet and medication allowed the astronaut to avoid the call of nature for a relatively long time. He did his business right before re-entering the atmosphere. When scientists analyzed his waste, they found out that its volume was 35% more than the average person's bladder could hold at maximum capacity. But the astronaut had no complaints about his condition, and he said the flight had been quite comfortable. I know that now when astronauts spend time inside a space station or a spacecraft in outer space, they sometimes wear their spacesuits for up to 9 hours. It means that using the regular toilet on board isn't really an option. The solution to this problem is simple: diapers. They are more advanced than the ones sold on Earth, of course, with a special absorbent sewn into the fabric. It can keep an astronaut's body dry for a long time. As you already know, I'm a high school teacher. If we went with my students on a school excursion to the International Space Station, the first question they would ask would probably be, "Tom, where's the restroom?" Well, of course, they would be also excited to learn about the cosmos, but it turns out that using a restroom in zero gravity might be quite a challenge, for which one needs to be prepared. If you take a hose in your backyard and start watering your flowers, the water comes out in a solid stream. The gravity captures it and falls where you aim. And in space, as you know, there's almost no gravity. So the water that comes out of the hose keeps flying in the same direction. And if you have to hit a precise target, it's even more difficult. The stream can break into droplets. They will start bouncing off the walls, going down and flying up. So if you're trying to use a regular toilet in space, you would be surrounded by flying droplets. The solution to this problem is to create a force that will attract the waste. If not gravity, then vacuum. Like the one we have in airplane toilets. After pressing the flush button there, you always hear a humming sound. That's the fan that starts pumping the air out of the waste tank. When the pressure is low enough, the hole in the drain opens and all the waste is instantly pulled down. And this is how the space toilet works at the International Space Station, where you have to create such vacuum from the very beginning. This way, the hose water will form a stream, not because of gravity, but the air pulled inside by a fan. Oh, and regular toilets won't do. If you need to use the bathroom on the ISS, you need to take a hose and turn the toilet on with a button. The fan inside will start spinning, pulling in the air. You'll do your business essentially into a vacuum cleaner. There's a unique funnel-shaped hose end so that both men and women can use the toilet. A suction airstream picks up all the droplets and directs them into the tank. Then comes the whole waste cleaning system with many filters and chemicals. There's also a tank of powerful acid. It's there to dissolve any solid formations in the waste. Otherwise, they can clog the filters and valves and complex systems and cause a breakdown. A leaky toilet is a very unpleasant thing when you're locked in a tight space without gravity. That acid can easily dissolve even some metals. That's why space toilet materials are made of special titanium alloys, super resistant and very expensive. After being cleaned, the waste gets turned into drinking water. It means that with time, you'll turn it into the garbage again and the cycle will repeat and repeat all over. Don't worry, the purification system works exceptionally well, so there's no harm in drinking the water. And your coffee also won't taste any worse. Things are a little more complicated if you run to the toilet for number 2. Then, just like on Earth, you'll have to lift the toilet lid first. At this point, the same fan as in the previous case turns on. It should already be working to prevent bad smells. Then it would help if you sat on the toilet, and here's another challenge. It's hard to do it in zero gravity. So there are straps for your feet and handles to hold on to. The fan does its job and your business goes into the waste tank. Paper and tissues go in there too. Each portion of solid waste then goes into a bag and gets sealed. And then the system sends these waste bags to a special canister. These canisters are stored on the ISS until a cargo spacecraft arrives there. The astronauts receive food and water supplies and scientific equipment. Then they load the cargo spacecraft with canisters of human waste and other garbage. After that, it undocks and prepares to return to Earth. But since cargo spaceships burn up entirely due to friction against the air in the upper atmosphere, all the waste gets disposed of before reaching the planet's surface. Another option astronauts have is to throw the canisters with waste directly into the open space. Earth's gravity eventually attracts the containers and they too burn up in the atmosphere. Currently, NASA is developing a system that could recycle waste of number 2 into water. After all, water is a precious resource on the International Space Station. So this space toilet, which is a little thing about the size of a scooter, costs around $23 million. That includes manufacturing and a dozen years of development. And this price doesn't even include the delivery to the International Space Station. For that money, you could buy a Bugatti Veyron, the most expensive car in the world, or something similar. Or a private jet, for example. Or you can become an island owner. You can even buy a few of them for that money. But okay, let's get back to space. The journey starts at the launch pad. The rocket that will later deliver the cargo to the ISS is assembled. Ignition! The rocket engines turn on. They burn hundreds of pounds of fuel every second. The rocket goes up, and when all the fuel is burned, the rocket's first stage undocks. It returns to Earth and makes a soft landing. The booster can be used again after refueling. Once the booster is undocked, the rocket's second stage fires the engines. More fuel is burned so that the rocket can reach the ISS altitude of about 250 miles above the sea level. Once in orbit, the cargo spacecraft docks with the ISS. And voila! The space toilet is delivered. But it costs about $50 million to launch a booster rocket like Falcon 9. We also plan to send people to Mars, and the trip will take them about 7 months. So we should create a comfortable bathroom for the astronauts probably. The design of the 23 million toilets is bound to be improved. Let's wish the engineers to make it smaller and lighter, so this way it uses less space and saves more fuel. Thank you for watching today, Brightsiders, and remember, let's learn something new every day together with Brightside.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see Supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Aww. Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him. one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardinia, and the star with the fastest movement across the sky, Bernard's star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
They say somewhere out there, there's a pen that can work in zero gravity, at extreme temperatures, and even underwater. They say this pen can write on almost any surface, or if you turn it upside down, or when your surroundings are heated up to 570 degrees Fahrenheit. They say NASA spent millions, or probably billions of dollars, and almost a decade to develop such a pen. The problem with ballpoint pens in space is that they don't work in the conditions of weightlessness. The ink can't flow to the ball normally since gravity doesn't affect it. Instead, pressure is created in the ink reservoir and pens start leaking. Some time ago, NASA used pencils, but wooden pencils were considered to be a fire hazard in most spaceships. All because, at that time, the atmosphere inside them was 100% oxygen. The need for a super pen was obvious. But whatever the rumors claim, NASA did not create such a pen, spending a fortune on the research. Its development was sponsored by Paul C. Fisher of the Fisher Pen Company based in Chicago. He spent over $1 million in almost 10 years to make a pressurized ink cartridge. It was supposed to allow space pens to function in zero gravity and other extreme conditions. Eventually, they got a pen that could write at a temperature of minus 30 to 250 degrees Fahrenheit, which is really impressive, isn't it? The pen was patented in 1966, and 1 year later, after conducting several thorough tests, NASA started to provide Apollo astronauts with such pens. Interestingly, the rumors about NASA spending an insane amount of money on the development of space pens have been circulating for decades. They have been debunked many times, but they appear again and again. Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of a sound effect, which is a totally false misconception. In space, no one will hear you scream. You know why? There's no air in space. It's an almost perfect vacuum. And sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Here's another one. All comets have beautiful long tails. It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. Now, let's look at a light year. This very notion makes us believe we speak about time here. But in reality, light years measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. Hey, do the math. Now, people often believe that in space, you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth, and the Sun doesn't float away from our home Milky Way galaxy. But the astronauts on the ISS experience not full-fledged, but microgravity, which means very small gravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Now, it may seem as if the Sun is always on fire. At least that's what it looks like in pictures. But in reality, our star is a giant ball of gas. Hey, I can relate. Nuclear reactions happening in its core at all times makes the Sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the Sun does emit blinding light and incredible heat. But it's not actually on fire, because no oxygen is involved in the process. A human can explode if they get into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk won't be as dramatic as it's often pictured in movies. A person will lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. Before it happens, the person should breathe out as much air as possible. Otherwise, this oxygen will damage their lungs from the inside. Then, without the protection of the spacesuit, which is like a mini spaceship, the pressure inside their body will drop. This will cause even more serious troubles. And even though this person definitely won't burst, they won't want to stay outside for too long. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star comes too close does a black hole spring into action. Even so, only those space objects that cross a certain border get ripped apart. If the Sun were suddenly replaced with a black hole, Earth's orbit wouldn't change. At the same time, Earth's temperature would be different. There would be no solar wind, and no magnetic storms created by the Sun would affect our planet. And let's say the black hole that replaced the Sun had the same mass as our star. Then, according to the law of physics, Earth would have to come very close to get pulled into this black hole. Now, the dark side of the moon myth was debunked more than 50 years ago. And still, not everyone knows that this dark side is simply part of the Earth's natural satellite that faces away from our planet. By no means is it darker than any other region of the moon, and sunlight falls equally on all sides of the satellite. It only seems dark because we never see this side of the moon from Earth, all because of the phenomenon known as tidal locking. Over billions of years, let me say that again, billions of years, the gravitational connection between our planet and its natural satellite has changed their orbits. The speed at which they move has also become different. And since Earth is way bigger than the Moon, the satellite's rotation was gradually slowing down, until at one point it reached the point of balance. And now, it takes the Moon the same time to make a full rotation around its axis and to fully orbit around Earth. Now, you might have heard people referring to Venus as Earth's twin. It's true that both these planets are of almost the same size. They have similar mass and composition. The surface gravity on Venus is 91% of that on Earth. So, if your weight was 100 pounds on our planet, on Venus you'd weigh 91 pounds. And still, calling these planets twins is a step too far. The atmosphere on Venus is 100 times thicker than that on Earth. Plus, its surface temperatures are insanely high, up to 850 degrees Fahrenheit. That's hot enough to melt lead or burn up your pizza. Venus has no water oceans or any life forms. It also rotates backward compared to all other planets of the solar system, including Earth. By the way, another myth claims that Mercury is the hottest planet in the solar system. After all, it's the closest planet to the Sun, but Venus is actually hotter. Asteroids strike Earth much more often than people tend to believe. But most of these collisions aren't history-changing extinction events. Most of them go completely unnoticed. Most asteroids that approach our planet are qualified as small, near-Earth objects. They usually burn up in Earth's atmosphere before they even have a chance to wipe out life off the surface of the planet. Not that they're big enough to do that. And still, around 40 to 80 tons of space debris fall on Earth every year. Most of this debris is tiny asteroids, also called bolides. They're usually no larger than 65 feet in diameter. That's small? Yeah, says so right here. Okay. So, once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the Great Supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP4365. It's a partially burnt white dwarf. Now, a white dwarf is a star that has burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. One of those zombie stars used to be a white dwarf, or just left over from an explosion. It gobbled up too much from another star and, surprisingly, managed to explode once again. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1,000,000 years over there because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. In outer space, you'd be strong enough to weld two pieces of metal together with your own hands. Okay, it has nothing to do with your strength. You could just press them together with no effort, and that's it. Oxygen in our atmosphere makes a thin layer on the surface of the metal. It's like a barrier, which is why such a trick is impossible on Earth, but perfectly logical in outer space. If you ever go to space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news? The skin is elastic enough to hold you together, which means you wouldn't explode. Yeah, small comfort, huh? If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around your eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, there's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space. If the fire breaks out in a rocket, you can simply turn off the ventilation system and voila! It can get more complicated if there's intense smoke, sparking, and material melting in conditions of reduced gravity. Regular foam fire extinguishers we use on Earth are useless here because they release foam randomly. Researchers are developing a fire extinguisher that will put out fires by using sound waves. The bigger the sound intensity, the bigger the flame they can put out. But the astronauts might end up deaf if the frequency is too high. A black hole is not like some starving monster that wanders around and has gravity so strong nothing can really escape it. When something comes close to the point of no return, which we also call the event horizon, it disappears. No way back. But quantum physics claims nothing can really destroy data, So it's a true paradox. Stephen Hawking was the one with the idea of how black holes don't really have event horizons. Maybe they have apparent horizons. Those trap things for some time only. After that, the trapped energy will somehow get away, but in a different form. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. It happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it in another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like 4 billion suns, but luckily it's far away from us. There are more than 23,000 pieces of so-called space junk bigger than a softball floating above our planet at speeds up to 17,500 miles per hour. Woo! And there are 500,000 pieces in general, some of them the size of a marble. Space waste is generally debris made up of natural particles called meteoroids and artificial particles, like things we make on the Earth. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world, from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space, but they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. There's a lot of it. It may even make 25% of the universe. Dark energy makes the rest of the 70% of the universe. Scientists don't know much about it, but they think dark energy could be behind the increasing expansion of the entire universe, while dark matter slows it down. Dark matter doesn't interact with us in any way that we know of, nor does it interact with itself. If it did, we might be able to find dark matter galaxies, dark matter planets, or such objects. Now, astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bit bored and wanted to check out how things were going in the direction of the cold spot. That's an anomaly in the cosmic microwave background map, or in short, CMB. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. But instead of CMB, they realized there's a giant area way colder than they'd expected. The team started tracking radio signals, but there were no radio sources in that whole volume. That means there are no galaxies or clusters, and since it's so cold, there's no dark matter either, or regular matter, so it really doesn't matter. The giant void is empty, and researchers think it could consist of dark energy. Light can still pass through it. It's not the only void in space, but it's the biggest one we've found. The area around a star is habitable when it's not too cold or too hot for liquid water to exist on the planet surrounding it. Let's say our planet was where Pluto is. It's too far from the Sun, which means our ocean and big parts of its atmosphere would freeze. But if the Earth was in Mercury's place, we'd be too close to the Sun, and the water on our planet would evaporate. Such habitable area is called the Goldilocks zone. So you can see where planets are located and assume if they have a chance for life on their surface. But Europa, one of Jupiter's moons, definitely breaks the rule. It's outside of the Goldilocks zone, but still kept warm. Not from the Sun directly, but Jupiter and its moons that actually pump energy into Europa. Europa changes its shape as it circles around Jupiter. It's similar to tides rising and falling on our planet. Water on the Earth changes its shape as a response to the tidal forces of our moon. When the same happens with a solid object, the object is stressed. That's how you pump energy into that object. It's like you're playing racquetball. You hit the ball around a couple of times before you start playing, like you're warming it up. You kind of distort the ball every time you smack it. The surface of Europa is frozen, but it has cracks in the ice. You can see ridges in the ice where there's a crack. Then those flying chunks shift and refreeze. You'd see a similar thing if you could fly over the Arctic Ocean in the wintertime. There are ice sheets constantly breaking and refreezing. So Europa can't completely freeze. Scientists think there could be an ocean of liquid water under the icy surface. Europa is not the only moon where this is happening. Another of Jupiter's moons, Io, is also warm because of such tidal forces. Io also has volcanoes erupting from within all the time. So it's not only that the sun warms the space bodies and pumps them with energy. Many experts agree the universe might come to its end about 3 to 22 billion years from now. It's expanding all the time, which means it formed from a compact state. If it has a beginning, it's probably going to have an end as well. Yeah, I won't be around for that. One of the popular theories says the growth will slow down, and gravity will become the powerful force that will make the universe shrink. That will lead to complete chaos. Galaxies, stars, planets, space bodies, they will all move, collide, and, destroy one another. It's like the reverse Big Bang. Huge chaos, but this time, everything collapses. Well, on that cheery note, always stay on the bright side of life.
Many people would like to fly into space. Zero gravity, a stunning view of Earth from one side, and the boundlessly frightening black area from the other. Yeah, it's all cool. But don't forget that this journey can turn into a nightmare. Lack of oxygen, floating in outer space and staying in a spaceship for a long time without understanding when you can return home. This last thing happened to a Russian cosmonaut. His stay in space is one of the longest in the world. 33-year-old flight engineer Sergei Krikalev spent 311 days in zero gravity on the Mir space station. But that's not the most interesting part of this story. Sergei's long journey began on May 18, 1991. That day, he boarded a transport ship and went into space to the Mir space station. On May 20th, the docking with the station was completed. There, together with another engineer, Sergei performed his space duties. They went on spacewalks several times, did repairs, took care of the station, and conducted scientific experiments. When you have company and a lot of work, living in space is not so hard. But things got worse on the day when Sergei was supposed to return home. According to the plan, the mission should have lasted for 5 months. A new astronaut was supposed to replace the old ones. The transport ship had finally docked with the station. But on October 10th, only one astronaut returned to Earth. Sergei was left alone at the Mir station. He continued to work as the sole flight engineer of the crew. The station couldn't remain empty. They had to send someone to replace Sergei. He wasn't ready for such a long stay in space. He hadn't trained for it. But there was no choice. He couldn't just leave the station. 1 month passed. They informed Sergei that he would return home soon, but something happened that no one expected. They contacted Sergei and said he couldn't return, since the country that promised to bring him home no longer existed. During this time, a big crisis began in Russia. The cosmonaut's return was impossible, since no one had the money for it. Just imagine Sergei's condition. You are hundreds of miles from home, in black outer space, completely alone, and have no idea how many days you have left to be there. The days passed slowly. Weeks, then a month passed. It would have been much easier if being in space was not harmful to your health. But in conditions of zero gravity, the human body takes serious damage. First, it's a weakening of the muscles. The body doesn't receive the necessary load it needs, and the muscles are constantly in a relaxed state, leading to dystrophy. Yes, astronauts do a set of exercises every day, but this is not enough to keep the body in shape. In addition to muscles, bones begin to weaken, and a person becomes weak. Even after 6 months of such a life, any astronaut needs a long time to get back into their previous shape after returning home. Also, there's a lot of radiation in space, which is dangerous for people. It comes from several sources at once. The main radiation comes from the sun. On Earth, we're protected from it, thanks to the planet's magnetic field. Almost all radiation accumulates in the upper atmosphere and doesn't reach us. This accumulation of radiation in the atmosphere is also bad for astronauts. But the worst radiation is the galactic one. It comes from distant stars and galaxies and has a powerful effect on all living things. Radiation provokes many unfavorable conditions and destroys the body at the cellular level. Now, all spaceships and the ISS are equipped with shields and coatings that reflect radiation. But still, it doesn't provide 100% protection. In space, the astronaut's immune system changes. There are no conditions under which immunity could improve. It seems that there's nothing wrong with the absence of many bacteria and microbes, but the body's defense is weakening. A person becomes more vulnerable to microbes that can be brought by another astronaut. You also have serious food restrictions. Food in tubes doesn't contain as many useful vitamins as it does in natural products. Without vitamins, the body weakens even more. And sometimes, astronauts have to go on spacewalks, which aren't easy. A spacesuit is a huge and uncomfortable outfit. It constrains your movements and puts pressure on your body. Work in space can last up to several hours. During this time, you sweat a lot. One of the suit's filters may be broken, and all the fluid released by your body can spread throughout the suit and reach your face. Your eyes may water. The drops could interfere with your vision. Thousands of dangers can await an astronaut during a mission in outer space. Imagine that you do some repairs and something goes wrong. The wrench jumps off the bolt and it flies out, for example. You try to catch it and unconsciously push off from the ship. You catch the bolt, but your body is already flying away. You have nothing to hold on to. But fortunately, you have a safety rope. Anyway, it can break off from your spacesuit because you attached it incorrectly. As soon as the rope breaks, your body changes the angle of flight. Now you're not just flying away, your body is spinning at this moment. The Earth and black space flash in your eyes. So you get it. There are definitely risks, but nothing like that happened with Sergei. All astronauts spend many hours training to be ready for any troubles. They gain good physical shape and lose it during the mission. Add to this the psychological factor. Your body weakens, you don't breathe fresh air, you can't see your friends, and you don't have the opportunity to return home. A small layer of wall separates you from the cold vacuum of space. All this causes stress, which also weakens your immunity and harms your nervous system. Fortunately, astronauts also get through serious psychological training. They can maintain self-control in the most stressful situations. But when you're alone in space for more than 6 months and don't know when you'll return, you can get seriously nervous. Fortunately, Sergei didn't panic. He performed his daily duties, trained, and of course, missed home. A month later, he received the same response. "We can't bring you back yet. The country is in a difficult situation." He felt worse every day. His strength was leaving him. He wasn't sure if he'd be able to survive. The most interesting thing is the station had a capsule developed to return to Earth. But Sergei didn't use it because no one would have served the station. Russia sold the station seats to other countries. Also, they hoped to sell Mir. This meant that Sergei had to keep the station working. Sergei's mission lasted twice as long as planned. As a result, he spent 10 months, or 311 days, in space and set a world record. During this time, he flew around the Earth about 5,000 times. Finally, he received the long-awaited message. He's coming home. Germany paid about $24 million for a ticket to the station. They were going to replace the astronaut. Krikalev got into the capsule and flew to Earth. Many people were waiting for his return down there. The cosmonaut landed, and everyone rushed to help him. He looked very thin, sweaty, and exhausted. 4 men helped him out of the capsule. They helped him stay on the ground, gave him a fur coat, and brought a bowl of broth. It seemed that such a flight would leave an imprint on his life forever. But the cosmonaut's mood was excellent. 2 years later, he went into space again and became the first Russian cosmonaut to fly on a NASA shuttle. And 2 years later, he was one of the first to live on the ISS. In 2005, he made his 6th and last flight. He went to the ISS, where he spent about 6 months, after which he returned home on the lander. After this flight, he set a world record for the total duration of stay in space, at 803 days. Only 10 years later, someone managed to break that record, but that's a different story. Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars, which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion, without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the Sun. Another protective shield that keeps the Earth safe from the Sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the sun's ultraviolet (UV) radiation and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it, but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.
Now, as a child, weren't you taught not to play with your food? Well, apparently these astronauts weren't. Floating Jell-O cubes across the cabin while in zero-G is a lot of fun, but it is also a sign of a potential problem called space euphoria. No one ever considered that extreme happiness in space could become a severe problem, but it can become a serious problem, and that's no kidding. For many years, space euphoria went undetected, although it was right there, front and center for all to see. When Apollo 14 astronaut Alan Shepard smuggled golf balls onto the moon and tried to create a tiny moon for the moon by attempting to hit a golf ball into orbit around the moon, everyone thought it was funny. Apollo 16 astronaut Charles Duke thought it would be funny if he tried to compete with the 1972 Olympic athletes back on Earth. He attempted to outjump the Olympic athletes to benefit from the 1/6 gravity on the moon. Duke jumped so high that he rotated onto his back and fell crashing onto the life support system in his backpack. It could have been a fatal fall if the bag had cracked. Duke's commander, John Young, said, "That's not funny," and it sure wasn't. Yet, when Apollo 17 astronauts began dancing and singing children's nursery songs while collecting rock samples, everyone still thought it was cute. Space euphoria again went unnoticed. As early as 1965, when Ed White became the first American to walk in space on a tethered spacewalk, his space euphoria became evident. He stayed out much longer than was necessary to test his mobility with the very first jetpack, or MMU as it was called, officially the Manned Maneuvering Unit. In his own words, "I'm not coming back. This is fun." Finally, when ordered to return to his Gemini spacecraft, Ed White said it was the saddest day of my life. Obviously, something sinister is at work with space euphoria. Weightlessness, combined with the view of Earth passing below, creates an exhilaration that overcomes all sense of duty. It is the great danger of space euphoria. Now, in hindsight, the effects of space euphoria could be seen when Apollo 17 astronauts drove the lunar rover on the moon. They exceeded the recommended speed limit and could be heard whooping and yelling as the rover rocked onto two wheels, even becoming airborne at times. Canadian astronaut Chris Hadfield was busy at work during his tethered EVA, extravehicular activity, when he paused to look over his shoulder. The glory of space smacked him in the face. He was so emotionally overwhelmed at the magnificent beauty of the Milky Way galaxy that tears began to fill up Hadfield's eyes. Now in space, tears do not flow down your cheeks. They pool up in your eyes. Hadfield had become blinded by tears of joy. But Hadfield, against protocol, refused to tell his supervisors on Earth. Only after he was no longer able to work did Hadfield speak a famous quote, "Houston, I have a problem." It was a direct result of space euphoria. Astronaut Hadfield managed to get back into the space shuttle, but his EVA was not fulfilled. Space euphoria had interfered. There is another aspect of space euphoria that deserves serious attention. It is something called the overview effect. Weightlessness in space affects everything from the physical and psychological health of the astronauts to the physics of using all the mechanical equipment of the spacecraft. However, weightlessness in space is not due to a lack of gravity. Astronauts orbit Earth less than 300 miles up, called LEO, low Earth orbit. There's plenty of gravity in low Earth orbit. The Earth's gravity keeps the Moon in orbit, and the Moon is about 250,000 miles away. In fact, a 150-pound astronaut would weigh 142 pounds in LEO. Weightlessness in space is due to free fall, not lack of gravity. What goes up must come down. The rocket blasts off, and about 8 minutes later, the engine shut off. The spacecraft begins to fall back to Earth. Fortunately, by this time, the rocket has achieved orbital velocity, which is about 17,500 miles per hour, so that it falls towards Earth but never hits the Earth. It keeps falling and falling around and around, precisely in the same curved path as the surface of the Earth. It's in orbit. It is free fall. Even though everyone calls it zero-G, it's not. If you were to place a bathroom scale under your feet when in free fall, it would show 0. You would weigh nothing. That's because the bathroom scale is falling too. The exciting thing is that astronauts retain all their muscle power. Their mass stays the same. Therefore, they can lift heavy equipment in space that would weigh hundreds or even thousands of pounds on Earth. Astronauts become superhumans in space, and that creates another unusual situation. There are lots of unusual situations in space. On the very first trip to the Moon, the Apollo 8 astronauts were not even scheduled to look back and photograph the Earth. Apollo 8 astronauts took only a limited number of pictures of Earth. That's unusual and kind of weird. But Earthrise from the Moon became perhaps the most influential environmentalist picture of the 20th century, and it wasn't even planned. But this is the key to understanding the overview effect: surprise at the unexpected. Even today, almost all globes of Earth are not of Earth. Globes in schools and libraries show each country, usually in different colors. Each country, sure enough, contains a star, but it is to mark the capital city of that country. It is not how the Earth looks from space. These globes are not globes of the planet Earth. In fact, it isn't easy to even find a globe of the planet Earth. Read the labels on these classroom globes. The geopolitical world. These are globes of a place called the world. There is no planet called the world. The world does not live in space. It lives on someone's desk or shelf. The definition of space is geological in origin. Space is defined as existing up to but not including the atmosphere of Earth. Earth isn't even an astronomical object. It explains why the very first mission to the Moon, the Apollo 8 mission, had not scheduled any pictures of Earth. Selfies weren't invented then. It also explains why the psychological impact of seeing Earthrise from the Moon was so profound. It was a unique and totally new perception for which any and all humans were utterly unprepared. Seeing Earth in space was a complete surprise. Imagine yourself floating in space outside the spacecraft. You are surrounded by the Milky Way galaxy blazing with millions of stars. The planet Earth is a blue marble passing beneath your feet. Pretty heady stuff. How would you react? Would it change you? Apollo 9 astronaut Rusty Schweickart felt strongly that he was what he called the sensing element for humanity. What does he mean? It's the overview effect kicking in. Schweickart felt that he was connected to all the people on Earth. He compared it to being born into a new existence. And astronaut Schweickart is not the only one who felt the overview effect. Apollo 14 astronaut Edgar Mitchell had this to say about being in space. It was rather an extension of the same universal process that evolved our molecules, and what I felt was an extraordinary personal connectedness with it. I experienced what has been described as an ecstasy of unity. I not only saw the connectedness, I felt it and experienced it sentientally. I was overwhelmed with the sensation of physically and mentally extending out into the cosmos. Some years after returning from space, astronaut Mitchell started an institute to study the brainwaves of people who had been in space. And yes, they are different. According to Mitchell's institute's research, the euphoric sensation of oneness with the universe creates brainwaves similar to meditating monks. Mitchell's studies were so significant that NASA launched a special Space Shuttle mission in 1998 just to study the effects of space on the brain. The Neurolab mission studied brain cells of laboratory animals, and the astronaut crew too, as brain cells try to adapt to the freefall environment in low Earth orbit. Well, we can't all be astronauts, but now we can all access virtual reality experiences of what the astronauts saw in space. The internet has opened up our earthbound point of view to share the unity and oneness of the overview effect, and give us a small taste of the space euphoria astronauts get in space. What can survive in space? Well, people can, if they have an excellent spacesuit. Spacesuits are, shall we say, kind of a needed item in the vacuum of space. Without one, you'll have to stay inside the spaceship or modular dwelling on the Moon or Mars. Currently, NASA has only several older spacesuits ready for use outside the spacecraft, like the International Space Station. NASA's Artemis mission to the Moon is planning to have new suits designed for both men and women. It has a $250 million budget for them. These new suits are much less bulky than the older ones and much more fashionable. But what other creatures besides people can live in space? 3 named animals were sent into space, and they all came home safely. Does that qualify? 2 dogs, Belka and Strelka, spent a day inside a Russian spacecraft in 1960 and became media stars upon their return. The USA launched a chimp named Ham on a 16-minute ride into space. Space starts 62 miles above the ocean level and only takes a rocket a few minutes to get there. Ham, who wore a spacesuit, performed all his button-pushing tasks admirably and is honored in the International Space Hall of Fame in Alamogordo, New Mexico. But tardigrades can actually live in space. Tardigrades, or water bears as they are often called, are brown and look like teeny tiny grizzly bears, and are one of the most miniature animals with legs. They have 8 of them. Most species of tardigrades have no eyes, but some do. It's possible to see water bears with a good magnifying glass, since they average about a ½ millimeter in size. Sprinkle a little water on moss and they'll come out. They can walk about 1 body length per second and run at about 2 body lengths per second. Water bear eggs are easier to spot because they're bright white. The European Space Agency took water bears to the International Space Station and left them outside for 10 days. They survived. They still survived with no air, water, almost a perfect vacuum, harmful solar radiation, extreme cold, and heat. Well, that doesn't sound very fun, does it? In extreme conditions, water bears rely on their exoskeleton, or tun, to protect themselves. In laboratory tests, this exoskeleton could withstand immense pressure at over 87,000 pounds per square inch. That's quite a spacesuit they got. Water bears have even been frozen solid for 30 years, and when warmed up, the water bears revived and were still able to reproduce. As we search for life in space, as we explore Mars, these types of extreme life forms become essential to understand. If water bears can survive literally every environmental condition, can we conclude that life is everywhere in space? Extremophiles are life forms living in extreme conditions, such as other planets might have. Mobile Cave in the country of Romania is one such place that could just well be on another planet. All life on Earth, on the surface of the Earth, is carbon-based. It means that carbon atoms act much like a universal Lego block, to which hydrogen, oxygen, and nitrogen atoms connect to form the molecules that the cells of living organisms are made of. But not in Mobile Cave. Mobile Cave was sealed off at least 2.5 million years ago. The water that percolates up through limestone rock has formed a lake in the cave, a mix of hydrogen sulfide, poisonous and corrosive, and ammonia. What could live in this toxic soup? Well, sulfur-based life forms. An entire ecological system without light or photosynthesis exists inside Mobile Cave. The food chain is built on chemosynthesis, microorganisms eating sulfur-based chemicals. 33 species of sulfur-based creatures were found living in the hostile environment of Mobile Cave. Shrimp, scorpions, centipedes, snails, etc., etc. Mobile Cave is an alien world deep underground full of sulfur-based life forms. If creatures like this exist in Mobile Cave on Earth, what can we expect to find living in outer space? Bacteria. Bacteria can live in outer space, and fungi too. Bacteria form the base of the food chain, and bacteria have been proven to be able to live in outer space. In the 1980s, cosmonauts on the Mir space station complained that something was growing outside the station's windows and blocking their view of Earth. It turned out, upon inspection, to be bacteria and fungus, or fungi. The windows, made of quartz, were being damaged and weakened by what was growing on the surface. Fungi were also found to be eating copper on some of the cables. Mold was found growing in some places on the outside of Mir. The space station was under attack by microorganisms. Scientists took this very seriously and began to investigate. It seems that in a sterile environment such as space, bacteria come out of their hiding places when no other microorganisms are around. Cosmic radiation may even help them mutate and adapt to the space environment. The bacteria seem to be growing even faster in space than on Earth. Years later, the United States decided to run a bacterial experiment on the International Space Station. They coated rocks with various bacteria and put them outside the space station. Some bacteria did not survive the harsh conditions of space, but many did. One strain called OU-20 survived for over a year and a half outside the ISS. Japan also did a bacterial experiment on the International Space Station. Outside the Japanese Kibo module, Kibo's robotic arm placed 3 panels with the bacteria Deinococcus radiodurans, or D. radiodurans for short. It survived outside in space for 3 years. The lead scientists of the Japanese experiment calculated that the bacteria could live as long as 8 years in space. That's long enough to make a journey to Mars and back 4 times. Now, this raises a couple of interesting questions. Could life have come to Earth from Mars in a space rock? And, more pointedly, could an infectious bacteria come to Earth in a space rock? Suddenly, what had only been considered in science fiction books and movies was now a subject of intense scientific scrutiny. And then came the Mars meteor. Antarctica is the best place to find meteors because it's covered by ice. The ice in the Allen Hills regions of Antarctica is locked in place by the configuration of the surrounding mountain. The ice here sublimes. That means the ice evaporates, never becoming liquid but turning directly into vapor. As the ice in the Allen Hills region sublimes, it exposes all the meteors that have hit the ice over many hundreds or thousands of years. Meteor hunters literally drive around on snowmobiles and pick them up with tongs, never touching them to avoid contaminating them with human bacteria. They bag the meteors, number them, and record the location and any other pertinent facts about the meteor. That's how meteor ALH 84001 was found, the Mars meteor. Since Earth gets hit by about 17 meteors every day, over thousands of years the numbers add up. Almost everywhere has been hit by a meteor at one time or another. 11 years apart, 2 houses on the same street in Weathersfield, Connecticut, had their roofs punctured by 1-pound meteors. But only a rare few meteors ever come from Mars. 126 meteors have now been identified as coming from the red planet. ALH 84001 came from Mars. Scientists know this because the United States has landed on Mars and sampled Martian rocks and the Martian atmosphere composition. ALH 84001 contained the same gases as Mars' atmosphere and similar chemical composition as the rocks. But the meteor also contained something else, a fossilized life form. There has been much debate about whether or not the tiny object inside ALH 84001 is a fossilized bacterial life form, or rather a chemical deposit. But the studies aboard the International Space Station confirm that bacteria can live for a long duration in space. So it is entirely possible that some bacteria could make the journey to Earth from Mars in a meteor. The United States Mars Exploring Perseverance rover has recently found organic molecules inside Mars rocks. These organics are carbon and hydrogen. It won't be known if these organic molecules were produced by living organisms or merely by chemical reactions until the samples are returned to Earth sometime before 2030. The search for life on Mars is ongoing. But Mars is not the only place in the solar system that might have life. Jupiter's moon, Europa, is a good suspect too. Entirely covered by miles of thick water ice, Europa may have an ocean of salty water beneath its icy crust. Ice acts as an insulation blanket. Combined with possible internal thermal processes in Europa's core, means that Europa's ocean water could be warm. The Europa Clipper Express mission plans to confirm conditions for life on Europa. Loaded with 9 pieces of observational equipment, the Europa Clipper will attempt to observe just about everything possibly going on by orbiting above Europa, including the chemical composition of the mysterious reddish-colored material that has ejected onto the surface ice from the ocean below. What could this reddish material be? Could it be a specific chemical mix? Or could it be krill, shrimp, fish, life forms like in Moville Cave? Or the ancient remnants of a brightside narrator? Stay tuned.
You're hovering about 18 miles above the surface of Earth and enjoying the best view of our planet. Whoa, that's a starfall! Make a wish. And that bright dot that's moving very fast is the International Space Station. And then, the waiter brings you a drink. Wait, why is there a waiter? Well, the thing is, you're on a tourist spaceship. And very soon, everyone will be able to fly into space with giant balloons. This is Neptune. It's a round capsule with panoramic windows and a 360-degree view. It can take on board 9 people in comfortable seats, including 8 passengers and 1 pilot. It also has an under-deck toilet. As the manufacturers say, it's the toilet with the best view in the universe. There's also a luggage compartment for tools and scientific equipment in the roof of the capsule, a Wi-Fi connection that will even allow live streaming, and there's a bar with refreshments. Space Perspective, the creators of Neptune's plan to price passenger tickets starting at $150,000. And there's no rocket engines, are there? This thing will go up thanks to a giant balloon the size of a football field. Let's move to the launch pad. Passengers enter the capsule. Engineers fill the balloon with hydrogen. It's lighter than air, so the balloon begins to take off. When the thrust becomes sufficient, the capsule with the passengers takes off from the launch pad. The journey begins. The capsule and balloon go up at 12 miles per hour. That's twice as slow as a person can run, and 2,000 times slower than a conventional rocket takes off. So you won't experience hard overloads, vibration, and noise like you would on a conventional rocket. So you're already at 45,000 feet. It's almost halfway there. This is where commercial airplanes fly. This is the frontier where the weather ceases to exist. No clouds, no wind currents or turbulence, but no oxygen either. You'd need an oxygen tank to breathe here, but the Neptune capsule is airtight, so you keep climbing. You also notice that the balloon has grown up several times. This is because we filled the balloon with hydrogen at 0 altitude. The hydrogen was putting pressure on the balloon from the inside, but the air from the atmosphere was putting pressure on the balloon from the outside. But the higher up you go, the less air there is. Hydrogen continues to pressurize the balloon from the inside, but now nothing is stopping it from expanding. So we need a very dense material that can stretch for the balloon. Humanity launches such balloons with weather probes all the time. They take off and get bigger as they ascend. But at extreme altitudes, the balloon material can't withstand the pressure, and it pops. The weather probe falls to the ground. We don't want the capsule with people to fall, so Neptune won't take off that high. But in case of emergency, Neptune has a parachute for safe landing. It's already deployed, and it's attached to the rope that goes to the balloon. So in case of unforeseen events, the parachute will instantly open, and the capsule will begin its slow descent. The entire takeoff procedure lasts 2 hours, and you reach the 100,000 feet mark. In human history, only about 20 people went to the stratosphere by balloon. The capsule hangs in the air. Now you and all the passengers have 2 hours to admire the curvature of the Earth, take endless selfies, and relax. You can even see a blue stripe over the surface of the planet. That's our atmosphere. And if you look up, you can see the most beautiful starry sky of your life. Because there are no clouds or light pollution from the big cities at this altitude, and you can see the stars in all their glory. For the same reason, we send our telescopes to this altitude. 2 hours have passed. It's time for the descent. This procedure is slow and gentle too. The balloon is lowered. Atmospheric pressure begins to press on it again, and it shrinks in size. The capsule will land on the water. It has a splashdown cone at the bottom for this purpose. This thing will help dampen the impact on the water so that everything happens softly and smoothly. 2 more hours of descent have passed. The Neptune touches the water. Now a ship is approaching the capsule. It takes the passengers on board and takes them to the shore. It also takes the capsule itself on board for relaunch into the stratosphere. But the balloon itself can no longer be used for a new trip. As soon as the passengers touch the ground, their journey is over. The first person to ascend to the stratosphere in a balloon was this Swiss man, Auguste Piccard. He designed this round gondola. It was airtight and could take 2 people on board. The gondola was attached to a huge balloon as big as a basketball court. As with Neptune, the balloon was filled with hydrogen. In May 1931, Auguste Piccard and Paul Kipfer began their flight. As they gained altitude, they discovered several problems. The airtightness of the capsule was bad. Air would escape from the capsule, but they were able to fix the problem. They were climbing higher and it was getting colder outside, but the temperature inside the gondola reached 100 degrees Fahrenheit because the crew couldn't control the air release valve, so they felt like they were in a hot desert. Auguste's gondola reached an altitude of 51,775 feet, only 16,000 feet higher than commercial airplanes fly now, and 17.5 hours after launch, Auguste landed back on the ground. During this and other flights, the scientists collected a lot of data about the wind in these layers of the atmosphere and cosmic rays. He was also the first person to send a radio signal to Earth from such an altitude. Later, Auguste Piccard used the idea of a fully airtight gondola to dive to extreme depths. He created a bathyscaphe, capable of descending to the deepest point on our planet, the Mariana Trench. Even though the Neptune is much more advanced, it still can't fly into space. It's not even close to it. So this is where Auguste Piccard was able to fly to. Here is the maximum altitude of the Neptune, but space much higher. This is the Kármán line, about 62 miles above sea level. Humanity considers this to be the boundary of our planet, so the tourist in the Neptune capsule won't even be able to feel weightlessness. But if you want to become a space tourist and dance in zero gravity, there are a few more options for you. This is a crude, suborbital reusable spacecraft. The journey starts on a regular runway, just like a commercial airplane. Here you can see the unusual White Knight 2 aircraft. It's as long as a tennis court and consists of 2 fuselages. Because of this, it has a wingspan as wide as a soccer field, and our Spaceship 2 is attached right between these fuselages. So, White Knight 2 takes off like an ordinary airplane, and reaches an altitude of about 12.5 miles. Then Spaceship Two undocks and begins an independent upward flight. This small spacecraft is the size of a swimming pool. It's controlled by 2 pilots and carries 6 passengers. Ignition. The rocket engine is on, and the spacecraft begins to gain altitude. The pilots and passengers have reached about 282,000 feet, almost 3 times higher than the Neptune balloon. The passengers were able to experience weightlessness for a while. Then the Spaceship Two began to land. The pilots didn't start engines anymore. They just glided in the air. Then the spacecraft released the landing gear and landed on the runway like a regular airplane. The creator of this company, which owns Spaceship Two, plans to carry out such tourist flights into space more often. The ticket for such a trip will start at $450,000. That's 3 times more than the flight on the Neptune balloon. If that's too much for you, we have another option for flying into space. This is the New Shepard spacecraft. This thing consists of a propulsion module and a crew capsule. It launches just like a conventional rocket, vertical takeoff, fast acceleration, and high overloads. The propulsion module helps the capsule reach a speed of about 2,230 miles per hour. At that speed, you could cross the United States from coast to coast in just 1 hour. The booster rocket climbed to an altitude of 65.7 miles. At this point, the crew capsule undocked and reached an altitude of 66.5 miles. The 4 passengers on board at this point felt weightless for several minutes. At this time, the launch vehicle descended to the ground and then made a successful landing. A few minutes later, the crew capsule began its descent. It launched 3 parachutes for braking. Just a few feet before touching the ground, the capsule makes a quick launch of the rocket engines to slow down completely and make the landing as soft as possible. You can become a space tourist and experience weightlessness on this rocket for only $250,000.
Another rocket blasts off from the launch pad and heads for the International Space Station. To deliver the payload there, you'd have to pay about $18,000 per 1 pound of its weight. Imagine spending that much money on just 3 bananas. So, the weight of the rocket and spaceship itself is calculated literally down to every bolt and every ounce. But engineers normally use about 600 pounds of white paint to coat the rocket. That's $10,800,000. Let's see. You could buy a 3-masted schooner, a gold-plated Bugatti Veyron, or a penthouse in Manhattan, maybe 2 of them, for this money. Or perhaps even a private island. Well, a small one. But engineers have to paint rockets white so that they don't turn into flying ovens. Imagine sitting in a black car in a parking lot at noon in the summer. The air conditioning is off. You'll start feeling uncomfortable in a couple of minutes. But if your car is white, it will heat up more slowly. It's all about the reflectivity of the material. When the sun's rays touch a black surface, they get absorbed. As a result, everything under this surface heats up. But when the rays reach a white surface, they get reflected. This surface absorbs much less heat. That's why you feel much hotter wearing a black t-shirt in the summer than while putting on a white one. You also look hotter. But I digress. Spaceships fly in space, and the temperature there is about minus 455 degrees Fahrenheit. But space is also a vacuum. That means there's no air particles that can transfer heat up there. So nothing blocks the sun's rays and prevents them from heating up the surface of the rocket to insane temperatures. If the rocket was black, it would absorb all those rays, and astronauts would feel like a chicken in an oven. Besides heat, the sun emits radiation. Earth's magnetic field and atmosphere protect us from its destructive effect. But there's no such shield in space. So the white paint on the surface of spacecraft also protects astronauts from radiation. Spacesuits are white for the same reason. So is the International Space Station itself. On Earth, most airplanes are painted white. But even with white paint on the paneling, a spacecraft can heat up too much, and its other side, where the sun's rays don't reach, will cool down a lot. After all, space is very cold. So, engineers came up with a clever way to transfer the heat from the sunny side of the spaceship to its dark side. There are tubes under the paneling. They're filled with ammonia. The ammonia evaporates after absorbing the heat from the surface. Then it transports this heat to the colder side of the spaceship. There it gives off the heat and returns to its liquid form. After that, the ammonia moves back to the illuminated side of the spacecraft. The second reason why we paint spacecraft white is that space is black, and if you paint your spaceship black or any other color, you won't be able to see it. This will make it difficult to dock spaceships with each other or with the ISS. But a white spaceship is perfectly visible against the black background of space. The third reason is that you can see even the slightest damage on the spaceship if it's painted white. Long before launch, the spaceship is assembled in a hangar from dozens of different parts. Then it's delivered to the launch pad. And if something went wrong in that process, you will see any scratch or crack on the white surface. Or if any part is leaking, you'll quickly notice a stain on the white surface. But it's not just the surface of spaceships and the ISS that gets painted white. The interior is white too. If you look at photos of astronauts on the International Space Station, you'll see that most of the interior is either white or beige. Again, it's all about the reflectivity of this color. Electrical power is an important resource on the ISS. Every light bulb and LED must be used economically, and white surfaces effectively reflect the light from the bulbs all over the station. This way, it isn't dark there even without a lot of lighting devices. And this is the Saturn V, America's moon rocket from the 70s. It's the biggest, most powerful, and heaviest payload-carrying rocket ever made. And it's not completely white. Even more interestingly, its white parts are painted this way to provide protection from the scorching Florida sun on the launch pad. But you can also see black stripes all over the rocket's body. Thanks to them, cameras on the ground can determine its rotation speed. The point is that at launch, a rocket spins exactly like an arrow fired from a bow. This helps it to be more stable during the flight. When the rocket is launched and starts spinning, all video cameras are pointed at it. When experts watch the video of the launch, they analyze every frame. They pay attention to how the black stripes move. This way, they can calculate the rotation speed of the rocket. Now, let's take a look at the space shuttle. You can always recognize it by the huge orange tank attached to the spacecraft. It contained liquid oxygen and hydrogen to propel the space shuttle into orbit, and it was orange because it's covered with insulating foam. Oxygen and hydrogen can only be in a liquid state at extremely low temperatures and under high pressure. So engineers tried to protect the fuel from overheating with this insulation. But originally, this tank was white too. The reason was the same, to reflect the sun's rays. But later, engineers decided that the foam insulation would be enough and the paint layer was removed. So they managed to save about 600 pounds of weight and deliver more payload into space. And 600 pounds is almost 72 gallons of water or 900 large burgers. Wow, how did that get on board? Interestingly, the space shuttle itself wasn't completely white. It had a black bottom. That's to withstand the extreme heat of re-entering Earth's atmosphere. When the space shuttle completed its mission in space, it started to descend. At the height of, let's say, about 400,000 feet, it traveled at 25 times the speed of sound. When the space shuttle re-entered the atmosphere, it literally collided with air particles and began to break. At this point, its bottom heated up due to friction with the air. Try rubbing your palms together, they become warmer. The same happened to the bottom of the space shuttle, only it heats up to 2300 degrees Fahrenheit. By comparison, the temperature of a hot frying pan is about 6 times lower. Just touch it and see. Nah, don't. That's why engineers had to protect the bottom of the space shuttle from overheating with special black tiles. They're called HRSI, which stands for High Temperature Reusable Surface Insulation. Catchy. They're made of porous silicon, which means they're very light but can withstand extreme temperatures. But when it comes to new rockets, we won't have to worry about painting them white or protecting them with tiles. We'll build new rockets and spacecraft with stainless steel because it's easier, cheaper, and faster. Take the SpaceX Starship. This thing will be able to take people to the moon, and in the future, even to Mars. And it's made of stainless steel. 2 pounds of carbon fiber, which is used in conventional spacecraft, cost about $200. But the same amount of stainless steel costs about $3. And since the weight of the spacecraft and booster is about 300 tons, the difference is huge. Stainless steel does a good job of reflecting the sun's rays, too. Even though it's dark, it's shiny, so the ship won't overheat. In addition, stainless steel is great at withstanding low temperatures, so it won't deform in cold space. And to save Starship from overheating on re-entry, its paneling is designed like a sandwich. There's an outer layer of steel, then a layer of air, and an inner layer of steel. Kinda like an Oreo. The air acts as thermal insulation. So, Starship with people on board is attached to the booster on the launch pad. Ignition. The booster helps Starship escape Earth's gravity, then it undocks. At that point, Starship fires its engines and enters orbit. By this time, it has used up almost all its fuel. Meanwhile, the booster re-enters the atmosphere and makes a soft landing. It docks with a refueling ship. Ignition. The booster launches again, takes the spacecraft into orbit, and returns to Earth. The refueling ship docks with the Starship and replenishes its fuel supply. It also transfers cargo to Starship. Then it undocks and returns to Earth for its next mission. At the same time, Starship turns on its space travel engines and heads for its destination. The journey to Mars will take about 7 months. SpaceX also plans to use Starship for traveling on Earth. Launches can take place from water platforms near big cities. Then, the trip to the other side of our planet will take no more than 1 hour.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown, 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere, due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
The snow-capped shape of Mount Taranaki, in the middle of Egmont National Park in New Zealand, is surrounded by a dense, dark-colored forest. It creates a gloomy green circle around the area. From above, the circle looks almost perfect. But it's only because of the local farmers. They use all the fertile soil they can, and it results in a contrasting color scheme. A near-perfect cone volcano, a rare geological phenomenon, has occasionally been erupting for over 100,000 years. It grew taller and larger after every eruption. It's predicted that in about 50 years, this volcano could turn the area around it into another Pompeii. In Italy, there's a unique spot known as the Giant Pink Bunny. You can find this humongous art project on the green fields of the Coleto Fava Mountain in northern Italy. The 200-foot-long and 20-foot-high bunny appeared in 2005. It was created by the art group Gelatin from Vienna. Not only does it have a strange and unique design, but it's also knitted. It took the team 5 years to finish the delicate structure. It used to be just like any other stuffed toy. Visitors could climb the bunny, taking in the views around them. But since it was placed on the hills, the art piece has started decaying. After all, it was only meant to last 20 years at the most. The once bright pink bunny has turned gray and has almost disappeared. If you look at the Google Maps satellite images these days, you might only notice its outline. While not as popular as Old Faithful, the Grand Prismatic Spring in Yellowstone Park, Wyoming is one of the most spectacular sights to see even from ground level. But from above, the bright bands of orange, yellow, and green really start showing their beauty. It's one of the biggest springs in the world, larger than a football field at 370 feet across. The hot water in it travels 121 feet to the surface. The spring is a feeding ground for heat-loving bacteria that change their color in the cooler water. A director searching for an unusual area for filming discovered a mysterious floating island in northeastern Argentina. Almost perfectly round and surrounded by a dark forest, it gives you an eerie feeling. No wonder the place got nicknamed the Eye. With the help of time-lapses on Google Earth, it was discovered that the inner landmass was moving around rather than sitting still as was first believed. A circle of land 387 feet in diameter, ranging from several inches to many feet in thickness, casually floats in the clear waters. It even rotates slowly, pushed by the cold water from below. This water is still being studied. It's completely exclusive to the surrounding area. From above, it looks like nothing more than a little island sitting in Homebush Bay, Australia. But zooming in will change that perspective. Once a successful trading port, the bay is filled with 4 abandoned cargo freighters that were too hard to remove. Once they became decommissioned, they were left in the bay and forgotten. The shipwrecked SS Airfield transformed from a broken-down wreck into a small but beautiful nature reserve. It's filled with thriving mango trees that have overtaken the ship and are slowly breaking down its hull. In the Gobi Desert, in the northeast part of China, bizarre symbols appeared in certain areas. This led to many theories of what they could be. Maybe ancient markings like the Nazca lines found in Peru. Guesses range from odd weather patterns and pipelines for some future development to target practice areas. But it turned out to be none of those. They're simply special symbols used to calibrate the cameras on China's satellites. The Badlands Guardian in Walsh, Canada, is one of the most famous and fascinating spots you can find on Google Earth. It looks like a man's head carved into the landscape. A feather headpiece that Native Americans used to wear sits on top of the head. It must be quite a modern design because the face also seems to have a pair of earphones. Unfortunately, it's just a simple road with an oil rig at the end. From ground level, the entire thing is not nearly as impressive. It looks just like any other exposed rock face that's been changed by the seasons. But this phenomenon is nothing more than the pareidolia effect, the same that makes you see objects in the clouds. An island on a lake, on an island in a lake, on an island is surely a mouthful. But Google Earth beautifully captured the place. A tiny island named Vulcan Point sits inside a crater lake on an island called Volcano Island inside a lake called Lake Tull on the Philippine islands of Luzon. It's one of the only 2 lakes in the world that have been discovered to have a third-order island in them. Tull Volcano is still active, and because of the large lake inside the crater, there's a risk of a volcanic tsunami. It can be triggered by debris falling into the lake after an eruption. This might create waves in the lake that can spill over the sides of the crater. The Firefox crop circle appeared in a cornfield in Oregon in 2006, but it wasn't some mystery or rare phenomenon. Celebrating the browser's 50 millionth download, the Linux users group from the Oregon State University created the giant logo. It was larger than 45,000 square feet. The group members stomped down all the stocks in a near-perfect circle. It was completed in under 24 hours after 2 careful weeks of planning. The final circle had a diameter of over 200 feet and was completely invisible from the road. It could only be appreciated from the sky. The most beautiful bright blue ponds are found at the Intrepid Potash Mine near Moab, Utah. Most potash forms in desert regions where inland seas or lakes dry out. As the water evaporates, it leaves behind potassium salt deposits. Most evaporation ponds are more reddish in color, but some dye was added to these particular ones. Dark water absorbs more sunlight and heat, speeding up the evaporation process. This leaves behind the salts much more quickly. Stunning aerial views of these ponds are a bonus. Making the largest advertising logo on Earth is something every marketing agency would dream of doing. And Coca-Cola did just that in 1986. The logo is an extremely large sculpture. It can only be viewed in its entirety from the sky. The biggest problem about such advertising, though, is that barely anyone knows about it. This huge Coke ad is 160 feet tall and 394 feet wide. It was built from 70,000 empty Coke bottles in northern Chile's Arica. The gigantic monument was created to celebrate the brand's 100-year anniversary. A guitar of this size can only be appreciated from extremely high above. The unusual shaped forest is located south of Cordoba in the Pampa region of Argentina. Known as the Guitar Forest, it extends for more than half a mile. It also contains more than 7,000 cypress and eucalyptus trees. A 74-year-old Argentine farmer, with the help of his children, managed to transform this piece of land into something magical, all done to pay tribute to his beloved wife. From high above, this area seems to be just a collection of boulders in the middle of a lake, but this is actually Hippo Pool in Tanzania. Hippos are common in all the rivers in the area, but this spot is certainly the best in the Serengeti to watch them playing around. The animals there swim in large groups of about 200 hippos. They stir up the waters and fill every square inch of space inside. If you can't get to Tanzania to see the spectacle, Google Earth gives you the opportunity to have this experience in the safety of your home. There are many large-sized pools in the world, and then there's the pool at San Alfonso del Mar, a resort outside of Santiago, Chile. Officially, the world's largest pool ever created. It cost nearly $2 billion to build. The pool is roughly the size of about 16 football fields. The water for the pool is taken from the Pacific Ocean. It gets filtered and treated multiple times a day to keep the gigantic pool clean. There's a saltwater pool inside a large glass pyramid, if you want to swim in a pool inside a pool. I'm getting confused. A strange and mysterious swirling pattern appeared in the desert of Egypt back in 1997. When this design was first discovered on Google Earth, it created a bit of a stir of what it could be. That was until it turned out to be nothing more than a giant art installation called Desert Breath. Two intertwining spirals are complete opposites. One spiral is piles of sand that are shaped like cones, and the other is made of mini craters. When the installation was first completed, the spirals led to the center of a circular pool of water. But since then, the water has dried out. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay